Hey guys, Mr. Milton here. Today we're going to talk about solving systems of equations by using the elimination method. And in this video, you should be able to solve systems of equations using elimination. Alright, the third and final method for solving a system of equations is the elimination method. Okay, what you do is you combine the equations together to temporarily get one of the variables. I'll say combine, but we'll want to add. Okay, to temporarily get rid of one of the variables. Okay, to do this, the coefficients in front of the variables you eliminate must be the same number with the opposite signs. Okay. Switch this up. All right. So, look at our example. We have 5x plus 3y equals 23 and x minus 3y equals 1. Which form are both of these equations in? Well, they have x and y on the same side. That's the standard form. Okay, and what are the coefficients for each variable? So as we look, we have 5, 5x, and 1x. We have 3y and negative 3y. Okay, so the coefficients are just the numbers in front. Okay, so 5, 1, 3, and negative 3. So, which variable are we eliminating? As you look back at what we wanted variables with the same number and opposite signs. So here we're going to eliminate the y. The y for k, because they have the same number and opposite signs. So let's solve this system. What we can do, 5x plus 3y equals 23, and x minus 3y equals 1. Okay. This system we call elimination. If you look at old school, talk to your grandparents or something, they called it linear combination. Okay, and what we're going to do is we're going to add these two equations. And that's why we want to have opposite signs. We want to have opposite signs so that we can add it. We don't have to think about everything or the signs each time. Okay, so we just add these two equations together. And so when we do add these two equations, we get 5x plus x, which gives us 6x. If you need to remind yourself that there is a number out here, write 1. Okay, hopefully you know that by now, but if you need to, write that down there. Give yourself that extra reminder. Okay, 3y minus y, because plus and negative is just minus. Okay, so 3y minus y eliminates that. Okay, that's gone. That's why I call it the elimination method. 23 plus 1 is 24. And so we get that 6x equals 24. Divide by 6. We find out that the x value is 4. Okay. And now that I know that x is 4, I can plug that value into one of the equations, and I'll choose the bottom one because, no, I want to. I don't know. It doesn't really matter. I can choose either one. Okay. And so now I'm going to, actually I'll choose that one. I'm going to plug 4 in for x to the top equation, plus 3y equals 23. 5 times 4 is 20, plus 3y equals 23. And now I'm going to solve for y. So I get 3y equals 3, divide by 3, and I find that y is 1. So I have my x value at 4, my y value of 1, and so my solution is 4, 1. Okay. Let's look at this second problem. Okay, sorry. All right, second problem, we have 6x minus 5y equals 27 and negative 6x minus 5y equals 3. Okay, as we look at the coefficients are the numbers in front of the variable. We see 6 in front of x, negative 5 in front of y. Negative 6 in front of x, negative 5 in front of y. Okay, so while this may seem tricky, we notice that these have opposite signs, the x's. So that's what we're going to eliminate. So I'm going to add these two equations together. 6x minus 6x eliminates the x's. They're gone. Negative 5y minus 5y is negative 10y. 27 plus 3 is 30. So I have negative 10y equals 30. Divide by negative 10. I find that y is negative 3. Okay. Now that I know that y is negative 3, I can plug that value in to top equation. So I have 6x minus 5 times negative 3 equals 27. So negative 5, negative 3, that's actually plus 15. So 6x plus 15 equals 27. I'll subtract 15 from both sides. 6x will equal 12. And then x will equal 2 after I divide by 6. And so my solution here will be 2, negative 3. Alright, again, remember that it does not matter what order you find the x and y. The x is always the first coordinate of your solution. The y is always the second coordinate of your solution. X, comma, y, always. Okay? Alright, so that's the basic solving systems by elimination. Okay. Okay. What happens if the coefficients are the same? Let's say are not the same. Okay. What happens if the coefficients are not the same? So we were really lucky in these first two problems to have, let's say, 6 and negative 6, or 2 and negative 2, and they were already opposites. Okay. What we can do is we can multiply one or both of the equations by a number to make the coefficients match up. Okay, and so let's look at some of those examples. Alright, so here we have 3x plus 2y equals 16 and negative 9x plus 5y equals 40. So as we look at these numbers, there are no numbers that are just opposite already. So we're going to ask ourselves, which numbers are going to be the easiest to make opposites? Okay, we have 3 and negative 9, and then we have 2 and 5. As I look at these numbers, I say, well, I can make this 3 a 9. And I can do that by multiplying this equation by 3. So I'm going to multiply everything, both sides of this equation, by 3. And when I do that, I'm going to rewrite that down here. I get 9x plus 6y equals 48. Now this helps me out because now I have my x's be opposites. So negative 9x plus 9x, as I eliminate that, it gives me 0. 5y plus 6y is 11y. 40 plus 48 is 88. So 11y equals 88. Divide by 11, and I find that y is 8. Once I know that y is 8, I can plug that into this top equation, really either equation, but I'm going to plug it into the top equation and say 3x plus 2 times 8 equals 16. So 3x plus 16 equals 16. Subtract 16 from both sides. I get 3x equals 0. I'll divide by 3, and I find that x is 0. So my solution then would be 0.08. X is 0, y is 8. Okay. Alright, so looking at number 2, we have 10x minus 3y equals 8 and 4x minus 3y equals 14. Notice here again we do not have our numbers that are just opposites already. So again, we're going to ask ourselves which numbers are going to be the easiest to make opposites. Okay. All right. So for number 2, the easiest way to make these opposites, because they're really close to being opposites, is I'm going to choose one of these equations to multiply by -1. Okay. When I multiply one of these equations by -1, then it becomes a positive 3y, and then we can eliminate that. Follow that thought, solve number 2. Okay, bring that completed. Alright, let's look at number 3. Number 3, we have 7x plus 5y equals 4 and 2x plus 3y equals 9. Again, we are not given two numbers that are just opposites right away, so we have to look and say which way is going to be easiest for us to make these opposites. Now, as I look at these numbers, 7 and 2, I have to multiply both of those, 5 and 3. Okay, as I look at this, I'm going to have to actually multiply both equations here. And so it really is going to be up to whoever's doing this problem to say which numbers they'd rather do. So what I'm going to do, I'd rather eliminate the y's. I know that that goes to 15, and multiplying by 3 and 5 seem pretty easy. So I'm going to multiply both of these equations by, well, I'm going to multiply this top equation by 3, and I'm going to multiply the bottom equation by -5. It's going to rewrite it over to this side. So I have 21x plus 15y equals 12, and then I'll have -10x minus 15y equals -45. Okay, and so you notice that I chose this number because I wanted to make sure that I got the y's to be the same number with opposite signs. Okay, and so now I can eliminate these. 21 minus 10 gives me 11x. 15 minus 15 gives me 0. 12 minus 45 is -33. So I'll divide by 11, and I'll find that x is -3. -3, don't forget that part. Okay. So x is -3. I'm now going to plug that back into an equation, either one, top or bottom. I'll plug it into the bottom. 2 times -3 plus 3y equals 9. So that gives me -6 plus 3y equals 9. I'll add 6 to both sides, so 3y equals 15, and divide by 3, so y is 5. So I have my y value at 5, my x value is -3. I'll say -3, 5 as my solution. Okay, final problem as we look through. Again, we do not have our numbers lined up so that we have an opposite given to us, and so easiest way that I see it is, hey, I'm going to multiply this bottom equation by -2. And so, as I rewrite this stuff over here so it's stacked, I'm going to have -4x plus 6y equals -10. Combine my equations, 4x minus 4x gives me 0x. -6y plus 6y gives me 0y. 10 minus 10 gives me 0. So really on this left side I have 0, and on the right side I have 0. Okay, I have no variables left. I have a statement that's true, 0 equals 0. Have infinitely many solutions. Okay. This last problem was considered a special case. What is the other special case? The other special case is no solutions. Okay, to get the same lines and infinitely many solutions, I should say infinitely many, so I don't just write I am. Both variables need to cancel out. And the numbers on the right side of the equation add to 0. To get parallel lines and no solutions, both variables need to cancel, and the numbers on the right of the equal sign are not 0. Okay, because if both variables cancel out, you'll end up with 0 equals something on this side, okay? And as long as it's not 0, it's no solution, okay? So essentially it's the same thing as substitution. If we get to a point where we have a true statement, like let's say 2 equals 2, 0 equals 0, it'll be infinitely many solutions. If we get to a point where 0 equals 5 or 0 equals anything other than 0, then it'll be no solution, okay? So, infinitely many solutions, true statement, no solution, false statement. Alright, so there you have it. You have one problem that I left you to do. Please try that problem out. Remember that you're just multiplying one of these by -1. If you need that extra kick, do the second one. Okay, and then as you do that, you should be able to solve it. Alright, see ya.